In this section, we're taking what we learned in the first section and expanding it from a 2 by 2 system, that's two lines with two variables x and y, and finding the point of intersection on the plane. We're expanding that out to be three equations with three variables. So this is three-dimensional stuff now. Anytime you have an equation with three variables, though, it represents a plane in space. So you've got the x direction and the y direction just like always, but now you have the z. And if you can imagine the z axis coming straight out from the board, then you can see that we can, I can't graph it, but we can think of things in three dimensions. Okay, so often, not always, but often, your three planes in space will intersect at exactly one point. You see this picture here that I stole from your book, where you have the blue plane, the yellow plane, and the green plane, and they all intersect at a point. Or if you can imagine two walls where the two walls meet, there's a line. Trace the line that's in the corner there up to the ceiling. The ceiling is a third plane. And where the two walls and the ceiling meet, you see that there's that point right there in the corner. So your job is to find where the three planes intersect in space and get that point. And if you do what I tell you to do, this process should only ever take 5 steps. Whether you choose to do it the easy way or the hard way, you should only ever have to take 5 steps. The most important thing that you can do to keep this as easy as possible is to choose the first variable wisely. You want to find the easiest way to eliminate the same variable in two different ways. Once you have eliminated the same variable twice, you're left with two equations that only have the other two variables in them. That gives you a system of two equations with two unknowns, which is just like what you did in section 1. So what you have to do is compare the coefficients of all the x's, the y's, and the z's, and pick the one that's going to be the easiest. You can choose whatever you want, but you want to choose the easiest way to do it. You need to multiply by whatever numbers it takes to get the same coefficient, opposite signs, just like before. It's just that now you have to do the same variable 2 times and then write down your answer, and then you have a brand new problem. It's just like what you did in the last section. Now, please, for your sake and for mine, always, always, always write down the variable that you intend to eliminate and exactly how you plan to do it. And you'll see how I've done that in the example on the next page. It's really easy to make stupid mistakes like adding instead of multiplying or dropping a minus sign, something like that. Forgetting to multiply the right-hand side of the equal sign is the most common mistake. So what you need to do is write down what you intend to do so that when you discover that you've made a mistake, you can retrace your steps instead of trying to resolve the problem. Finding your own mistakes is the hardest part of this chapter. So write down what you intend so that it's easier to find your mistakes. All right, let's do an example. Okay, the first thing we have to do is choose a variable to eliminate. You want to do this wisely because you don't want to work every problem the hardest possible way. So let's look at the x's. When you look at these x's here, you see that this has a coefficient of 1, which can be multiplied by whatever we want to eliminate both of these, but they're all positive. Now, when you look at the z's, you have a negative z, but you also have a negative 2 here. So you would have to multiply by a negative 2 to get a positive to eliminate this guy. When you look at the y's, you have a positive 1y. The other two guys are negative, so y is going to be the easiest to eliminate. So I'm going to write down what I intend to do. And then write down exactly how I intend to do it. I'm going to be using some notation here, row 1, row 2, and row 3, that you'll use if you ever have to work with matrices. So you'll be familiar with it when you get to that point. So here we go. We're going to take row 1 and multiply that by 3 and combine that with row 2. When we do that, this will be a positive 3. We have a minus 3 right here. When we add the two rows, y will be eliminated. The second choice of what we want to do is take the top guy, the positive 1, multiply row 1 by 2, and combine with row 3. You see how you are getting this to be a positive 2, combining with a negative 2, which will again eliminate y. So step 1, let me write this down. Step 1, you're going to eliminate the chosen variable. Step 2 is to do it again. Eliminate the same variable a second time. So let's do this. You always and forever, amen, write down what you're doing. So the first thing I'm going to write, I'll do my busy work in blue here. The first thing I want to write is 3r plus r1. So taking row 1 and distributing a 3, multiplying this whole thing by 3. You've got to multiply both sides of the equal sign so you still are equivalent. So we've got 3 times 2x, 3 times y, 3 times minus 2z, and 3 times a minus 1 on the right-hand side. The next thing we're going to combine with row 2, so I just copy this row as it is. 3x minus 3y minus z equals 5. Combining those, I'm going to get 9x. The y's go away. Minus 7z equals 2. That's going to be the first equation in the next system that I'm going to solve. Doing step 2, I'm going to multiply the top row by 2, combine it with the bottom row. So I'm going to multiply through both sides of the equation. 2 times 2x plus 2y minus 2 times 2 is 4z equals 2 times a negative 1, which gives me negative 2. Copy row 3 as it is. Combine. Notice right from the beginning, though, I forgot to mention, all of your x's are lined up in a column. All of your y's, all your z's, all your equal signs and numbers. If it's not in that form to begin with, you need to put it in that form. And you'll notice that in the homework, some of the variables are already eliminated. That takes care of step 1. You move on to eliminate that same variable using the remaining 2 equations. So the point of what we're doing is to take 3 equations with 3 variables and create 2 equations with 2 variables by eliminating the same variable in 2 different ways. So let's continue. 4 and 1 is 5x's. The y's are eliminated, which was the whole point. Minus z equals 4. So now you see we have a brand new system that's just like the ones we did in the last section. 2 equations with 2 variables. Now, step 3, eliminate one more variable. Eliminate one variable. When we eliminate one more variable, then we have solved for the third variable. So what do I plan to do here? Which one would be easiest? The z. The same sign, but this is a 1. So I'm just going to multiply this by -7. Looks nasty, but it's not bad. Row 1 combined with -7, row 2. Write down your busy work. Row 1 stays the same. 7z equals 2. And now 7 and a negative sign through the bottom row gives me -35x's, +7z's. Let me clean this up a little. And multiplying the right-hand side by -7 is going to give me -28. Combine. 9 minus 35 is -26. The z's are gone. And now combining here, I get -26. And look, when we solve, we get x equals 1. Simple, simple, simple. Let me do that in black. X equals 1. Step 4, back substitute to get the second variable. Substitute. So I'm going to take the x equals 1 and back substitute into one of these guys. I choose that guy. So here we go. We have 5 times x minus z equals 4, minus z equals -1, z equals 1. So now we have 2 of the variables, x equals 1, z equals 1, but we have to find y. So step 5, I told you every single one is 5 steps. I'm going to take both of those things and back substitute into one of the originals. So I choose, because I'm solving for y, I choose to substitute into the top guy because he's got a plain old y. So x is 1, z is 1. Whoops. Sorry, guys. So 2 x's. Sorry again. 2 x's. Sorry. X is 1 plus y minus 2, z is 1 equals -1. 2 minus 2 goes away, y equals -1. Now, that is not my answer. My answer is an ordered triple, a point in space using the x, y, and z coordinates, and it's ordered because it's in alphabetical order, x, y, z. And there is this unique point in space where these 3 planes intersect each other.